Hello, Mr. Price here, and this is the final question on the June 2005. This is question 8, and it's one we've seen kind of before in the paper, actually. We have another projectile question. So, we'll look at the first part. And we have our particle, and it's projected with a speed of 49 meters per second at a certain angle of elevation. Okay, and it moves freely under gravity, so there's no other forces acting on it other than gravity. And we can say that the horizontal and upward vertical displacements of the particle from O are given by these various values here. And we want to express the x and y displacements in terms of theta and t, and we should eventually get a formula that looks very much like this one. Okay, whenever we do this, it always follows the same kind of trend. So first off, we have our particle here. We're going to model our question. So our particle is fired with a speed of 49 meters per second at some kind of angle theta. Okay, so there's basically going to be an upward displacement and a horizontal displacement. So first things first, let's get a value of the horizontal displacement, because this one's nice and easy. So when there's no force acting on it on the horizontal plane, that means it's not accelerating, so it follows our simple rule of distance equals speed times time. Okay, so replacing with the values that we actually want here, so our distance here is our displacement in x, our speed is 49 cosine alpha multiplied by t. So 49 cosine theta t. Now, let's now resolve. So that was resolving. Can I focus this a little bit? It's a little bit better. So that was resolving this way. Okay, I'm going to leave a little bit of space here because I'm going to come back to this shortly. Now, resolving in the vertical direction, resolving upwards, I have my initial speed as 49 sine theta. My displacement in y I do not yet know. My acceleration is negative 9.8 and t. Okay, it gave us in the original. Don't be put off that we don't have, or we're missing two values here. It wanted it in terms of t anyway. Okay, so don't worry too much about it. So express it in terms of theta and t. So we're not worrying too much about that. So we're just going to call it t. So we know that displacement in y, or sy, equals ut plus half at squared. And here, let's substitute in, so sy equals 49 sine theta t plus, minus 4.9 t squared. Okay, now we want to link, there we are. We now want to link these two equations together. And what links them? Time. So, let's equate this to t. So t equals the displacement in the x direction divided by 49 cosine theta, and I'm now going to substitute this into here. It will eliminate t and give me an equation in terms of its horizontal and vertical displacement. So, sub, let's call this 1, sub 1 into 2. So we'll get sy equals 49 sine theta multiplied by sx, all divided by 49 cosine theta, minus 4.9 lots of sx squared all over 49 squared cos theta squared. Okay, let's do some cancelling out. So sy equals, okay, so these 49s are going to cancel out, and this sine divided by cosine will equal tan, so we'll get is that 5? No, sorry, so sx tan theta minus, so 4.9 divided by 49 squared will cancel out minus 4.9 and slightly cancel this out. So if you do that on your calculator, you should get sx squared at the top, and then 4.9 divided by 49 squared should give you 490 cos squared theta. Okay, and now here we'll keep this as it is because this is looking very similar to what we wanted, x tan theta, which is good. Also, so we've got our x tan theta. We now want our x squared at the top, which we have. We have our 490. We just now want 1 plus tan squared theta at the top. Okay, so I know that cos squared theta is equal to 1 plus tan squared theta. So I can now just do a slight change here. Sx tan theta minus sx squared lots of 1 plus tan squared theta all over 490. And that's our job done for part I. Okay, let's have a look at part 2. The particle passes through the point where x equals 17, y equals 30, and the two possible values for theta and theta 1 and theta 2. Okay, so we've got an acute and or a steeper arc that gives us the same values, and we want what these possible values are. Okay, so fairly simply, we're going to substitute these values into the equation we've just worked out. So 30 equals 70 tan theta minus 70 squared 1 plus tan squared theta all over 490. So 30 equals 70 tan theta. Oh, you can't see a thing, sorry. 30 equals 70 tan theta minus minus 10 plus 10 tan squared theta. So I don't really like it in terms of these tans, so let's let A equals tan squared theta. And I'll do some rearranging. So 30 equals 70A minus 10 minus 10A squared. And now we've got a nice quadratic. So 10A squared minus 70A plus 40 equals 0. And now we just use the quadratic formula, or if you have a decent calculator, your calculator will do that for you. And eventually we should get A equal to 6.3723 or A equaling 0.6277. So using A equals tan squared theta, we'll eventually get a theta value of either 81.1 or theta value of 32.1 degrees. And that's part 2. Okay. Finally, let's have a look at part 3. So, that's question 7. We now want to find the distances between A1 and A2. So, we have our values of theta now for these two possible situations. So we know theta 1 was 81.1 degrees and theta 2 is 32.1 degrees. So now all we want to do is find these distances. So in other words, we want to know what the x displacement is for both of these values. So let's go back to our original equation. So Sy equals 49 sine theta t minus 4.9 t squared. And we're just going to use these two values. So 49 sine 81.1, lots of t, minus 4.9 t squared equals 0. Because we want the time that it hits the ground. So this forms a quadratic equation, which once you solve, we get a time of 9.877 seconds. So now that we have a time, we can substitute this back into our Sx. So Sx equals 49t cosine 81.1, and this gives us a displacement of 74.8756 meters. Okay, observe how I'm using my really old equations. There's nothing stopping you from using the one given in the question as well. This is just what my previous notes have made for some reason, but there we are. So that's our displacement in the x direction for the steep one. And we'll now repeat this process for the steeper angle. So Sy equals 49 sine 32.1 t minus 4.9 t squared. And doing some various bits, we get a t value to be 5.314. So then using Sx equals 49t cosine 32.1, we get a value there of 220.578. So we'll find the difference between them. So delta Sx is equal to 146 meters. Okay, you may have done that a different way, but if you get the same end result, it really doesn't matter. I hope that was of help, and that concludes all of our videos on this paper. Thank you very much.